Welcome to this explainer. If you're a GCSE student looking to truly nail your energy topics and lock in those top marks, you're in exactly the right place. We've designed this as a highly structured revision tool specifically for mastering renewable energy. We're going to strip away all the fluff, focus purely on what you actually need to know, and build up your knowledge step by step. Let's get into it. But right before we dive into these specific types of power plants, I want to test your active recall. What actually makes an energy source renewable? It sounds like a pretty simple question, right? But examiners are looking for a very specific scientific understanding here. It's not just about a resource being green or clean.
Okay, so here is the exact exam board approved definition you're going to need. Renewable energy is an energy source that is naturally replenished over time and is not expected to run out on human timescales. Basically, it replaces itself naturally. Now, a really crucial point to keep in mind here is that just because a resource is renewable, unlike fossil fuels, it definitely doesn't mean it's perfect. As you'll see in a minute, they still have some pretty significant downsides, like massive installation costs, environmental impacts, or just sheer unreliability.
So, here's our game plan for this explainer. First, defining renewable energy. Then, wind and solar power. Next, hydro, tidal, and wave. After that, geothermal and biomass. Then we'll compare the resources and wrap up with some essential exam tips.
Just to ground this in the real world for a second, if you look at the projected U.S. utility-scale electricity generation for 2025, renewables make up about a quarter of the pie, 24% to be exact. Wind is actually leading the pack there, followed by solar and hydro. This really proves why this topic matters so much globally. We are literally in the middle of a massive energy transition, and these technologies are scaling up incredibly fast to eventually replace that massive 76% chunk of non-renewables.
All right, Section 1, Wind and Solar Power, or as I like to call them, the Intermittent Giants.
Let's break down the basic mechanics. With wind power, moving air physically turns these massive turbine blades. Those blades are connected to a rotor, which drives an electromagnetic generator to pump out electricity. It's essentially just capturing kinetic energy. And a fun little fact for you, a single blade on a modern wind turbine can literally be longer than a jumbo jet. Solar power, on the other hand, works completely differently. Photovoltaic, or PV cells, convert sunlight directly into electricity with absolutely zero moving parts. It's just a clean, direct conversion of light energy.
Now, what's really fascinating here is how both of these completely different sources share the exact same major drawback. The advantages are fantastic, obviously. Once they're built, the fuel is absolutely free. Wind and sunlight don't cost a penny, and they produce very low greenhouse gas emissions while they're actually operating. But the massive disadvantage? They are completely unreliable. They're strictly dependent on the weather. If the wind just isn't blowing, or if it's nighttime or really cloudy, your electricity generation drops off a cliff. In the energy industry, we call this intermittency.
Moving right along to Section 2, Hydro, Tidal, and Wave. This is all about water-based power.
The big player here is hydroelectric power, or HEP. This simply utilizes gravity. A massive dam creates a huge reservoir of water. When that water is allowed to rush through pipes in the dam, it spins turbines connected to generators. What's absolutely brilliant about this is something called pumped hydro. During times when electricity demand is low, say in the middle of the night, we can actually use excess electricity on the grid to pump water back uphill into the reservoir. It stores potential energy, so it acts just like a giant water battery, totally ready to be released the second peak demand hits.
So the crucial point here is weighing those massive operational benefits against the initial environmental impacts. HEP is highly reliable. Unlike wind and solar, you can just open the gates and generate power almost instantly to respond to grid demand. But the disadvantages are pretty severe. Building these dams is wildly expensive, and more importantly, especially for your geography exams, it requires flooding huge valleys. That forces people to relocate and completely destroys local habitats and ecosystems.
Staying with water, we also have ocean technologies, and this perfectly illustrates a distinction you really must make in an exam: tidal versus wave power. Tidal power utilizes the natural rise and fall of the ocean tides, and because tides are driven by the moon's gravity, they are totally 100% predictable. We know exactly when the water will move. Wave power, however, uses the motion of surface waves, which are driven by the wind. Therefore, wave power is unpredictable, just like the wind itself.
Next up, Section 3, Geothermal and Biomass. We're talking earth and organic power.
You can actually break down the word geothermal to understand it perfectly. Geo meaning earth and therm meaning heat.
In certain places around the world, especially volcanic regions, the heat from the Earth's magma comes pretty close to the surface and heats up underground water. We can actually drill deep wells and pump this superheated water or steam straight to the surface to spin a turbine.
Geothermal is fantastic because it provides what we call reliable baseload power. The Earth is always hot down there, right? So it generates electricity 24 hours a day, 7 days a week, with very low emissions. However, the big disadvantage here is that you're strictly limited by geography. You can't just slap a geothermal plant anywhere. You have to be in specific locations where the Earth's heat is actually accessible near the surface, like in Iceland or parts of California. Next up is biomass. This refers to organic material, think wood chips, crop waste, or even some types of garbage that can be burned to produce energy. We can also turn plants like corn or sugarcane into liquid biofuels. Now pay super close attention here because this is important. Biomass is often described using the carbon-neutral theory. The idea goes like this. The carbon dioxide released when you burn the wood is perfectly balanced out by the carbon dioxide the tree absorbed from the atmosphere while it was growing. But here's the crucial point. In real life, biomass is rarely perfectly carbon neutral. This is a very frequent trap in exams, so watch out. While it's great because it's renewable and uses up waste efficiently, you have to account for the entire life cycle. Growing those crops requires heavy tractors, processing the biofuels requires massive industrial plants, and transporting the wood requires diesel trucks. All of those steps produce actual greenhouse gas emissions. Plus, growing fuel takes up huge amounts of land that could otherwise be used for food or natural forests. All right, Section 4, comparing the resources. This is the big synthesis. You'll want to take a mental screenshot of the information here. Notice the really clear patterns when we weigh these pros and cons against each other. Wind and solar are amazing for the environment, but they completely fall short on reliability. Hydroelectric and geothermal, well, they solve that reliability problem, but they create geographical and habitat issues. Biomass solves the waste issue, but then introduces land use and transport emissions. Understanding these exact trade-offs is your absolute golden ticket for answering those tricky 6-mark evaluation questions. And finally, Section 5, Essential Exam Tips. It's all about nailing those keywords. Memorizing and deploying these exact keywords is going to prove your deep understanding to the examiner. Don't just casually say wind is unreliable. Call it intermittent or weather-dependent. Always contrast the predictable nature of tides with the unpredictable nature of waves. When you're talking about dams, explicit phrases like habitat destruction or flooding valleys are what score the points. And finally, when discussing biomass, always clarify that it is carbon neutral in theory, but not always in practice. That little bit of nuance shows top-level understanding. As we wrap up this explainer, I want to leave you with a final, slightly provocative thought. As we transition away from highly reliable, steady fossil fuels, we're moving toward a grid that's dominated by wind and solar. But as we've just seen, those are intermittent. So how on earth will we balance a future energy grid that relies so heavily on the weather? Will it be massive batteries? Will it be a huge expansion of pumped hydro? Managing that grid stability is arguably the ultimate engineering challenge of your generation. Thanks so much for joining me on this deep dive. Keep reviewing these concepts, and best of luck with your revision.